So we now come to squeezing and expanding arrays within NumPy. We're going to start with squeezing NumPy arrays. So the squeeze operation allows the reduction of NumPy array axes by dropping a specified axis, so long as the axis is of unit length. The product of the shape of the resulting array, which is the overall size of the resulting array, remains the same as that of the original array, however. So here we're going to look at an example. This is an array which comprises of 4 batches and 1 row and 5 columns within each batch. We see that by calling the numpy.squeeze function on this array, the resulting array has shape 4, 5. As we can see, the axis of unit length has been dropped. We can also specify the axis along which we want to squeeze. So let's look at an example. We have the numpy.squeeze function, and we pass in the array that we want to squeeze as one parameter, and the axis along we want to squeeze as another parameter. We can see that the resulting array has now been squeezed along the dimension that we have specified. Now we're going to look at unsqueezing or expanding NumPy arrays. So unsqueezing is the direct opposite of squeezing, where a unit axis is inserted at a specific position. We can also add on multiple axes by using a tuple on the axis attribute of the expand dims method. So we're going to look at an example here. So we have an array of 4 rows and 5 columns, and by calling the numpy.expandDims function on the array and specifying the axis along which we want to increase the dimension of the array, we see that we can add a unit dimension inside our original array. The Y array, which initially had 4, 5 as its shape, is now expanded to 4 batches, 1 row, and 5 columns. We can also add multiple axes of unit dimensions to the array itself. We can utilize the numpy.expandDims function again on this array and specify the axes as a tuple. As we can see, the output array's dimension is 1, 4, 1, 5 as we want to insert a new axis at the position of 0 and the position of 2.